So I would like us to look at AP and GP quickly. Yeah. On AP and GP, so our main focus is on sum of an AP. So for the sum of an AP, we all know that the formula for the sum of an AP. We have been learning about AP and GP from in grade 10, 11. So we did AP and GP there. So here, the question which is mostly asked in exams and pure sheets is how to derive out the formula for sum of an AP. So I would like us to derive out the formula for the sum of an AP because this question is mostly asked in quizzes and sometimes in tests and exams. So you have to know how to derive out the formula for sum of an AP. So let's do our first example. She's saying derive out the formula for the sum of an AP if the nth term is not known. So if the last term is not known, how can you derive out the formula for this AP? So let's go to solutions. So number one. So we all know that the first term of an AP is given by A plus the second term is given by A plus D. Then plus the third term is given by A plus 2D. So this is the third, second, and third term. You know that this one goes on over and over and over again. So we have looked at the first two terms, three terms. So let's look at the second last two terms. So for the last two terms of an AP, they are given by A plus N minus 2D. Then plus the last term of an AP is given by A plus N minus 1D. So this is the from the first to the last because you don't know the number of terms. So this is from the first to the last. So yeah, this is implying that there are more here. So this is the formula for sum of an AP. So S of n is equal to this. So now if this one we have written it from the first to the last. So we can write it again from the last to the first. So let's write this same equation from the last to the first. So S of n is equal to, so the last part is A plus n minus 1d, then plus the second is A plus n minus 2d, then plus the dot carries on. Then let's now write from the first. So A plus 2d, then we have plus A plus d, then you have A plus A, which is our first term. So as we can see here, we have started from the here we started from the first, here we have started from the last. So we can add the first and from the first one and the last one. So we can add this one and this one, 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 this one, this one, this one, this one. So let's quickly do that. So let's add the first term and the last term. So if s of n plus s, if you add s of n plus s of n, you're going to have 2 s of n, which is equal to, if you add a plus this, so a plus a, you're going to have 2a. Then this one is just alone, so plus this, so plus n minus 1 d. Then plus, if you add this, the second term and the second formula, so we have a plus a, you're going to have 2a plus, if you add n minus 1d with this one, so d times n, you're going to have dn, d times you're going to have 2d, so 2d minus d, you're going to have 1d, so which is going to give you back the same thing, which is n minus 1d plus that again to continuous plus again. If you add from the last here, you have the last element is a plus n minus 1d. For this one, if we write it, the first one is a, so a plus a, you're going to have 2a plus n minus 1d. So as you can see, if you add from the first one, starting from the first, and if you start from that, if you start adding the elements, they'll give you the same answer continuously. This one, this one, this one, they are all equal. So that's how it is to be giving you the same answer. So in this way, this we don't know the number of these because there are those say there are many of these, so there are n of these. We don't know the exact number of these, so there are n of them. So we are going to have 2 s of n is equal to, so we're going to get out of this, we're just going to get out just one. So we're going to have 2a plus n minus 1 d. So we have just gotten out of one of these because they are all the same. Now we don't know the number of these because they are a lot. So these you can represent them by letter n. So we have n multiplied by all of these because we don't know the number of these. So that's why I've introduced a letter n here because we don't know the exact number. So if you divide by 2 here, if you also divide by n, so the sum will be given by s of n is equal to n over 2, then 2a plus n minus 1 d. So this is the formula for the sum of an AP if the last term is not known. If you don't know the last term, so this is the formula which you use for an AP. So let's now look at our second question. So our second question is saying derive out the formula for the sum of an AP if the nth term is known. So suppose you know the last term is known. How can you derive out the formula for the an AP? So you know the last term. So for this one, we did not know the last term. So now for the second question is saying if the last term is known. So let's go direct to the question. So question 2. So we know that the first term is given by A1, then plus the second one is A plus D, then plus. So this can carry on. So let's go to the last part now. So the last part is AN minus 2D plus AN minus D, then plus AN. Because we are reducing this, so you're going to have minus 2D minus D, then for this one you're going to have not D, so you're going to have AN. So now we can also rewrite this again. So S of n is equal to, so S of n is equal to, so if we rewrite this, you're going to have AN as our first term plus AN minus D, then plus AN minus 2D, then plus, you carry on plus. So our first, this one is, which is A plus D, then plus A. So I've written this one from the, this one is from the first to the last, this one is from the last to the first. So again you also have to add again. So if we add s of 1 plus s of 1, you're going to have 2 s of n, which is equal to, so if you add the first term and the last term, I'm going to have a plus a n. So you're going to have a plus a n, then plus, if you add this one and this one, you're going to have a plus. So d minus d, you're going to have 0. So you're going to have a plus a n, so which is a plus a n, then plus continuous. So we go here, a n minus d plus a plus d. So d minus d, they can, d and d they cancel because one is negative, one the other is positive. So going to remain with a plus a n. So plus a plus a n, then plus a n plus a, you're going to have a plus a n. As you can see, these are just repeating each other, they're just repeating. So you're going to have 2 Sn is equal to a plus a n, because we just get one of these because these they are repeating, there are many of them. So all of these, because you don't know the exact number of them, we put them to be n. So this is n. So if you know the number of these, if there are 20, you just, where there is n, you just put a 20 because you know the exact number of these. So where there is n, you just put a 20. So now even here you can divide by 2, you divide by 2. So Sn is equal to n over 2, then 2a plus an. So therefore, ladies and gentlemen, this is the formula if the last term is known. So if you know the last term, you have to just use this formula because you have the first term which is a plus the last term which is an. For some books and tutorial sheets or what you are going to see, the an you are going to put, they will be putting here which is the last term. So don't be surprised. So this is one and the same thing. Yeah. So this is the formula. Continue with our example. So let's go to our example 3. So the example 3 is saying the integers from 12 to 55 are added. What is their sum? So the integers from 12 to 55. So you have integers from 12 to 55. So they have been added. So what is their sum? So they're adding from 12 to what? To 55. So we got the expression of number 3. So we know that the first term is what? 12. Then difference is what? 1, because integers they are numbers from 12 to 55. So the difference is 12 with 13. So the difference is just 1. Then the last term, which is an, is what? 55. So for this one, since the last term is known, that we have two formulas here. So this one is if the last term is not known, then this one is the nth term is known. So we're going to use this formula because we have our last term, which is 55. So we all know that the nth term of an AP is given by an is equal to a plus n minus 1 d. So this is the formula for the nth term of one AP. So we have to use this formula to find the sum. Now we don't have our n here, so we have to look for n. How do you look for n? We use this formula for the nth term of one AP. So for other textbook or materials, you're going to be saying Tn is equal to this formula. So others they use an, so don't be surprised here. So we know that our first term is what? A, which is 12. Then an is 55. So we put here 55 is equal to, what is our a? 12 plus n minus 1. What is our g? 12. Oh, our g, sorry, is 1. Sorry. So we're going to have 55 minus, okay, is equal to 12. Then 1 times, then you're going to have n. 1 times 1 minus 1. So 12 minus 1 gives you what? 11. So we're going to have n is equal to 55 minus 11. So our n will be equal to, so 55 minus 11 is equal to 44. As simple as that. So then you go, we now get back to this formula. So s of n is equal to n over 2, where a plus a n. So s of what? 44 is equal to, so we have 44 over 2. Then what's our a? Our a is 12 plus, what is our an? Our an is 55. So s of 44 is equal to 4. 44 divided by 2, are going to have 22. So 12 plus 55, this gives us 67. So you have 22 multiplied by 65, it's equal to 67. So s of 44 is equal to, so you can just calculate on your calculator. So 22 multiplied by 67, so 2 times 7 gives us, okay, let me just calculate it quickly. 22 multiplied by 67. So this gives us 1474. So this is the sum of the first 44 terms of an integer starting from 12 to 55. So as simple as that. So you all know how to use these two formulas, because for this one you have to use it if the last term is known. Then this one, if the last term is not known but the nth term is known. Yeah. Then this question is saying the sum of the first 8 terms of an AP is 12, and that of the first 16 terms is 56. Find the AP. So to find the AP is to find the first term, the second term, and the third term. You can go on, but just find any number of terms you want. So for this one, you can do it on your own. Yeah, you can do this one on your own, but the formula you have to use is this one. I'm going to send the solutions, but the formula you have to use is this one, not this one. So use this formula and solve for the first terms of for the terms of an AP. As simple as that.